Hi, I'm Bob. I spent the last 2 years designing a network as a service portal for a Silicon Valley startup called Graphient. In part one of this series, I used a railway metaphor to illustrate the difference between big telecom's expensive business class lines, MPLS, and modern solutions that rely on smart routing over SD-WAN. Our ultimate design goal? A single pane of glass. One dashboard showing real-time data for every circuit, edge device, and site on the network. The theory is simple. No more guesswork or juggling multiple tools, just a clean, unified interface. But a single pane can easily become a big pane if your data sources aren't reliable. Fancy diagrams are worthless if half the feeds are missing or misleading. We learned that the hard way. Setting everything up took massive spreadsheets and endless manual entry. One slip up, and you'd redo an entire site's configuration. From a customer's perspective, spending 3 months on data entry drudgery just to update the MPLS wasn't a great pitch. So we made a bold bet. Automate the worst steps and slash onboarding time by 50%. Our target was to cut 6 weeks off of a typical 3-month rollout and also reduce support tickets by 40%. Our initial fix? Swing and a miss. CSV imports. The idea here was to dump all the configs into a spreadsheet, click upload, and done. In theory, it saved manual steps and made demos self-service, but it assumed perfect data and no edge cases. The moment columns were mismatched or fields were missing, we needed a robust UI for error resolution, negating the simple portion of the solution. We also tried labeling everything with hierarchical tags, like level 0 for regions, level 1 for domains, and level 2 for sites. It borrowed from older setups, think Cisco ACI. Also, these tags only helped with traffic policies. They didn't handle device configs or site's overall layout. So yeah, it did something, but it wasn't the all-in-one approach that we really needed. After spirited discussions, we pivoted to atomic design. Instead of forcing every little site into rigid layers, we defined each key piece of data, like a WAN circuit's name, provider, speed, as an atom. Each atom stands on its own, so we're not stuck with the top-down structure. We can mix and match these atoms for different sites, protocols, or devices without hacking up a rigid hierarchy. This gave us a real shot at faster onboarding and cleaner updates. If atoms are values, we combine multiple atoms, speed, QoS, redundancy, into a molecule, such as a WAN circuit settings form. Now we have a cohesive unit defining one functional piece in a network. Now at the organism level, things get a little bit more complex. We embed a circuit module into a device interface, plus any sub-interfaces or routing protocols. Multiple molecules come together in a single actionable device config. And finally, templates. This concept had been sitting in our backlog for about 1.5 years. And with it, we could avoid configuring each device one by one. For example, a standard security posture or routing policy could be pushed as an update to several devices, instantaneously propagating to all of them at the same time, massively cutting manual steps. With the entire network configuration largely automated and centralized, the atomic approach turned a sprawling, spreadsheet-heavy nightmare into a streamlined system. With each layer, atoms, molecules, organisms, and templates, we drastically reduced onboarding time and made that single pane of glass both real and reliable.